Okay, welcome back to day 2. Testing volume really quick. Okay, looks like we're good. All right. Today is a lesson on histograms. Now, just another reminder. Okay, so we're all in lesson 2. You must be using the same notebook that you used for the last one and that you used for your class assignment yesterday or the day before, wherever it was. All right. Please make sure you have your notebook. This is super important. Make sure your name's written on the notebook in Sharpie. Make sure that the subject's written on there. These are going to be crucial to your success in the notebook quizzes, okay? So it's really, really important that you have that. So make sure you have a calculator. Today, not so much to worry about the graphing calculator, but it is coming, so please make sure you have a graphing calculator. So conceptual is a little long again today. Not really long, just a lot of slides. So this should be a super easy lesson. It's histograms and a few other graphs, okay? The first sections are about organizing statistical data. So yesterday we talked about frequency distributions. Now we're going to look at some other pictures that we can use to see what our graphs look like. Okay, this is a histogram. All right, hopefully you've done histograms before in middle school or in other math classes. So a histogram is a graph that displays the data by using contiguous, I don't think I'm saying that right, vertical bars, unless the frequency of the class is 0, of various heights to represent the frequencies of the classes. So this is a beautiful picture to show what our data looks like. It's a pictorial representation. It gives us an image for this to see what it looks like. So you'll notice on these for the frequencies, you'll notice here on the bottom that it uses continuous. Okay, that's super important. You can't have gaps in a histogram, so it uses the class boundaries, not the class limits. Okay, moving on. So this is another type of graph. We're going to talk about 3 graphs today. This is a frequency polygon. Okay, very, very similar to a histogram, except for we're using lines and dots. These points here are the midpoints. Okay, remember last time we had the midpoints? This was Y. So that we could graph and get another visual representation. It's a line to show us. It's just a different one. It's called frequency polygon. The third one is called an ogive. Now, I will be honest with you, this is not a graph that shows up very often. In fact, I'm not even sure I'm pronouncing it right. Before I taught this class, I'd never heard of it before, and if I had, I'd completely forgotten. So it's a cumulative frequency graph. So this is one of those graphs that it uses the cumulative frequency from your frequency chart, and it basically it's showing us how it's rising. Is it going up quickly? Is it going up slowly? How are we accumulating our frequency? This, again, is not something that we use very often. You do have to know it, but it's not very common. So this last picture, this picture is in your book. I would use this, I refer back to this quite frequently if you can. This gives us an idea of what our data looks like. And there's different names for them. So you'll notice if it's nice and even like this, it's called a bell-shaped. Okay, if all of them are right around the same, it's called uniform. That means there's no variation in our data. Okay, a J-shape means that it is small in the smaller numbers and large in the bigger numbers. Okay, a reverse J-shape is just the opposite. Okay, these two, the J-shapes, are not very common as well. We don't hear these terms used very often. Right and left skewed. Now, you will notice that the right skewed is larger on the left side. Okay, that's because we're saying it's skewed to the right because it's there's more variation on the right side. Okay, not more variation. It's more spread out. Okay, and left skewed, you'll notice it is larger on the right. So it's just the opposite of what you think it's going to be. And my picture here, I'm going to move this just a little bit so we can see the bottom ones. Okay, this is a bimodal. This is sort of like a bell shape, except we have 2 bells. You notice the 2 bells like that? Okay, and a U shape is the opposite of a bell because there's a U in the middle of it. So those are our different shapes of graphs. So sometimes I'll ask you to comment on the shapes of a graph and what it means for that data. All right, example 1. Now, everything before this you did not have to write down. This you do. Okay, this is a once we start doing the examples, you must do them. Now, if you have some graph paper, your pictures will look prettier than mine because mine are freehand here. So this gives us the frequency chart. It also gives us the scores, but it doesn't give us it in the with the class boundaries. It gives us the class limits, but we don't have to write those on the frequency chart. You just need to do them on the histogram. So on my histogram, create. All right. I am going to. You notice that my frequency goes from 2 to 26, I'm going to go up by 4s, okay, just because of the space. So you need to decide what you're going to do. Please make sure that all of these numbers are evenly spaced, that I don't go 4, 6, 9, all right? So these are evenly spaced. Okay, if I have graph paper, it would look better. 12, 16, 20, 24, 28, okay? So I'm only going to what I need. And then down here, I can start this wherever my data starts. So I'm going to start this now. I'm going to use the class boundary. So we're going to go 201.5 to 204.5. Okay, and again, they should be evenly spaced. All of these bars should be the same space. So I'm going to kind of wing it here and try to make sure these are all exactly the same. That one's a little small, but they should be the same. So 204.5, and then I have 207.5, and then I have 210.5, 213.5, 216.5, and 219. All right, and now I'm going to create my bars. So from 204 to 202, or 201.5 to 204.5, there was only 2. So this is a small bar, about half this size. Okay? Then the next one is 7, so it's almost to the 8. This is going to be, again, I'm freehanding this, so it's not perfect. Okay? This one goes up to 16. 16. Okay? This one goes up to 26. Let's make sure I'm in the right spot. 210.5, 213.5. So this goes all the way up to right here. Then I go to 18, which is this is a little bit bigger than the 216 one, and 4. Okay. Now you'll notice this isn't a perfect bell-shaped curve, but it is pretty close. So I could call this a bell curve, which means that the data is evenly distributed. So. All right, now you're going to pause, create one yourself, and then check your solution. Here's your solution. I'll move this so that we can see it all. All right. Again, it shows everything. This is not all that you have to write them down. If you've shown your work for what you did before, you may. That's all you need for the notes. Example 2. Now we're going to create a frequency polygon. Remember, this is a little bit different than the histogram. We're going to create it with midpoints. So to find the midpoint, you add the numbers together, divide by 2. In this case, since it's 202 to 204, the midpoint is 203. It's actually fairly easy to find. 206, 209, 212, 215, and 218. So again, if you have graph paper, these will look much prettier. Okay. Now I'm using basically the same frequency chart that I used before, so I'm going to keep these the same. 4, 8, 12, 16, 20, 24, 28. But here, I'm just going to have lines with my midpoints. So 203, 206, 209, 212, 215, and 218. And then I'm going to create little dots. And then I'm going to play connect the dots. So 203 I have 2. 206 I have 7. 209 I have 16. Okay, 212 I have 26. That's right up here. This isn't going to be perfect because of the way that. Okay, and then 18 is going to be just above the 16, and 4 would be around there. And then I'm going to connect the dots. Alright, that is a frequency polygon. Okay, moving forward. Here is your example. You must create a frequency polygon. I kept the data the same, so you'll be using the same data that you did before. You'll need to find the points and move on. So go ahead and pause, create your frequency polygon, and then check your work. Here's your solution. Oops, moving the wrong thing. This. out of the way. I hope that's enough out of the way. And pause, check out your solution. Example 3, last one. This is creating an, okay. All right, now, this I need to keep paying attention to. I need my cumulative frequency. So this one's 2, 9, 25, 51, 51 and 18 is 69, 73. Okay. So when I do this, my scale is going to be a little bit different. I'm going to, because I have to go all the way up to 73, so I'm going to actually go up by tens this time so that I can make sure that I have enough space for everything. 10, 20, 30, 40, 50, 60, 70, and 80. Okay. So I'm going to keep I'm sorry, I just lost my train of thought. Oh, guys. Okay, so the guys are, when we plot the points, they're at each of the upper boundaries. So when we do this, we're going to plot them at the upper boundaries of each one. So this is not midpoint, this is upper boundary. So 204.5, 207.5, 210.5, 213.5, 216.5, oops, sorry, 216.5, and 219.5. So, okay, when you plot the points, they must be at the upper boundaries of your frequency. So remember, you should have all of these already because this is the same data that we have for the rest of them. So this is going to be at 2. This is going to be way down here. And okay, it's not matching up with my pen. And then 9, so we're going to be just above, like right by 10, just below 10, but it's not, my marker's not matching where I'm writing on the board. And then we're going to go to 25, try to make this a little bit closer. 51, 69, and 73. And then we're going to connect the dots to kind of show how it's moving. So, alright. Now, here is your practice problem. Please pause, do your practice problem, then check the solution. Here's your solution. No, we're going to move this one completely out of the way, probably up here. Alright, so there's your solution. Check it, make sure that you've got everything done right, and I will see you tomorrow.